So we introduced logistic regression with two categories for simplicity. But once you have the basic idea down, nothing really changes. Well, that's not true. A lot changes, but the basic idea remains the same if you have multiple, more than two categories. So back to Palmer penguins. Previously, we contracted this. We had Adelie and not Adelie. Here we just have the three categories. And our goal will be to find the probability that each penguin is in each of the three categories. And once we've done that, we can classify them. We can pick the highest probability. Here's why I first said that not a lot changes, and then I said, well, that's not true. I sort of contradicted myself because both those statements are true. Nothing changes in the sense that we're still finding these z values, but something does change in the sense that we're now finding three z values, one for each species. And again, the question of how we find these betas, that's what logistic regression is doing. Logistic regression is finding the B's in the best way that it can. And sort of the same thing down here, where not a lot changes, but also everything changes. I mean, when we just had the two categories, we had one divided by an exponential, essentially. One divided by one plus an exponential. Now we have an exponential divided by the sums of exponentials. As I say, doing the logistic regression means finding the best values of the coefficients, in the sense that we get the best predictions. And I did misspeak a little in the last video. I said something like we want the most correct predictions or something like that. I mean, predictions can be right, but one can still be better than another. Like if we think it's 51% likely that a species is Adelie, versus if we think it's 99% likely. I mean, if the species is Adelie, that second prediction is better, even though they are both correct. Even though they're both correctly identifying the species. Likewise, predictions can be wrong, but one can still be better than another. If a penguin is Adelie, and one set of coefficients thinks it's Adelie with 1% probability, and another thinks it's Adelie with 40% probability. Both these predictions are wrong, but the second prediction is better. So we're not literally just counting successes and failures. We're doing something a little more sophisticated. We're trying to be as right as possible, and when we're wrong, we're trying to be as less wrong as possible.